Right, what we're going to look at now is we're going to find the vector product form of an equation of a line. So writing the vector equation of a line a different way. Now, you know a couple of things already. You know that if you have the cross product of two vectors and that equals 0, you know that that means that vector A and B are parallel or collinear. Means the angle between those vectors is 0 because they're linked by sine theta from that new formula that we've got. So if I gave you a vector equation of a line, and you're used to these from Pure Core 1, so what we've got here is a vector equation of a line. So you've got direction vector 2, 1, 3, and you've got position vector 2, 1, 3, and you've got direction vector 4, 1, 7, and your parameter is lambda. So we might think of this as written in a different way. A is our position vector, that's like our anchor, it works like the intercept if we were looking at a Cartesian equation. And here we have our vector that would be acting as a gradient. So, and we're going to call that V. So that would be another way of writing it. All I'm going to do is rearrange this as though it's algebraic. So I'm going to subtract vector A off both sides. And what that's saying is that the vector, R take away A, is equal to a multiple of vector B. And if a vector is a multiple of another vector, it means that that vector is parallel to that vector. So we can see that the vector R minus A is parallel to vector B. Using your cross product, using the idea that we mentioned here, we can then rewrite that in a totally different way. We can write it as the cross product of vector R minus A and vector B equaling 0. So that is the vector product form of an equation of the line. So an example of this might be a line has a vector equation with position vector -2, 1, 3 and direction vector 3, -5, 1. Write this equation in vector product form. So all you would do is you would rewrite it as R, take away your position vector. You would group that together as a single vector, so you put brackets around it. You then take your cross product, and it's the cross product of your direction vector, and you know that that equals 0. And that is your answer. Just to check if that's the case. There we have it. There's your answer.